Okay, this is the AP Physics Fall Final Exam Whiteboard Review. In number 1, it says, in the design of the supermarket, there are to be several ramps connecting different parts of the store. Customers will have to push grocery carts up ramps, and it's obviously desirable that it not be too difficult. The engineer has done a survey and found that almost no one complains if the force required to push is no more than 25 newtons. Ignoring friction at one maximum angle, theta, should the ramps be built, assuming a full 22 kilogram grocery cart. Okay, so I have my picture here, and I need to figure out which angle to build this. Okay, so imagine my free body diagram. I think I'm going to draw it right on here. So there's going to be a gravitational force straight down. Weight of the cart from Earth. There's going to be a support force straight up. Cart from the ramp. And there's going to be this push force. So a force from the push. So force on the cart from the push. So we're assuming this is going at a constant velocity here. So hopefully you can see that this side should be the same as this side of the triangle. This length should be the same side as, or same length as that side of the triangle. I would suggest rotating your coordinate axes. So let's say this is my x-axis, and here is my y-axis. And here I can go ahead and make this triangle. Hopefully you can see that this angle right here is the same as this angle. And this is a 90-degree triangle, just like this whole thing is a 90-degree triangle. So if this angle is the same as this angle, which is the same as this angle, then that means that this angle up here is that theta. Okay. So I'm going to write a couple equations here, and that's going to be in the x direction. X direction, I'm going to say that the force on the cart from the push must be equal to the x component of the weight, W, C, E, X. And in the y direction, the normal, the support force on the cart from the ramp must be equal to the y component of the weight. Okay, so let's see. I know what that force for the push has to be. It says no more than 25 newtons. So that's going to be equal to the weight of the cart times, or in the x direction. So let's see, that's going to be sine of the angle, sine of theta. So 25 newtons equals, I think it said it was a 22 kilogram cart. So the weight would be 220 newtons times the sine of the angle. And I can go ahead and solve for the angle. I believe we end up getting 6.95 degrees. Excuse me, no, 6.5 degrees. I'm not sure if we can get it over here. Let's see, we don't know the support force. Again, we know that the weight will be 220 newtons times the cosine of the angle. So we'll notice this angle here, this is the adjacent side, so cosine is going to be, I have two unknowns, so I can't really figure out what the support is, so I can find the answer. So from that equation,